Here we are again with the topic sequence at the convergence, and it's time for the question practice. So the question is limit 3n plus up to n plus of 1 is equal to 3. We know by the using the unit formula, but we solve for the sequence and the convergence. Okay, so it's time for we prove that this is equal to. Okay, we use the convergence of basically the sequence of numbers. Like we talk about definition, which was that xn minus of x is f less than the epsilon for n is greater than equal to k, or where k is greater than epsilon. These are some definition which was important in this. Okay, now using the first definition, so our question become 3n plus of 2 divided by n plus of 1 minus of 3 is less than 3, and solving the upper limit, this become minus 1 divided by n plus of 1 less than 3. Okay, and we can say that because the modulus 1 upon n plus of epsilon 1 upon n plus of 1 is less than epsilon. Okay, so basically we want to prove 1 upon n. It is true or not, we will check. Okay, now this we check by this. Now we know that 1 upon n plus of 1 is greater than n plus of 1 is greater than n, so 1 upon n plus of 1 is less than 1 upon n. Simple logic. And we know like all the numbers which is greater than the small number, so there is the reverse is basically the same, which is epsilon. So we can use like that. So by this we can see that the 1 upon n plus of 1 is less than epsilon. We can say because it was less than the 1 upon n, so it is true. So if it is true, we can say that the limit of 3n plus of 2 divided by n plus of 1 is equal to 3. That was true. Okay, now the second question is a great question. So the question is, we prove like the limit of root n plus of 1 minus of root n, it is 0. Okay, we use the same definitions like modulation, the upper limit plus of 1, the final limit minus initial limit which was less than the small number. So we let's see it is true or it is not true. By rationalization, we can see that if we put the rationalization, we can say that 1 upon n plus of 1 basically become 1 upon root of n plus of 1 plus of root of n. It is less than 3. We can say that 1 upon root n plus of 1 plus of root n, it is always less than or maybe equal to 1 upon n root n, and the 1 upon root n is greater than 1 upon n because n is greater than root of n, so 1 upon n is less than 1 upon root n. Okay, and 1 upon n is, you can see that. Okay, so 1 upon root n is greater than 1 upon n, basically 1 in the rooting way. And we can also say that the 1 upon root n is less than epsilon because 1 upon n is less than epsilon. So since 1 upon root n is also greater than the 1 upon n, so you can also less than the 1 upon epsilon, basically the epsilon. So the overall it is like 1 upon root n plus of 1 plus of root of n is less than epsilon, and by which we can say that this is true, and the limit of n plus of 1 minus of root n is 0. Okay, I hope you understand the concept which I explained in you simply you understand the step. So I hope you understand, and the next class we go to the topic which was the tails of sequences. Okay, next we go the topic which was the tails of sequences. I hope you read it before on the class. Bye bye.